Application to investigation and sports events. In maximal activity such as a 100-meter sprint, the main energy system used would be initially the ATP/PC system for the first 10 seconds, and then this would change to the lactic acid system to complete the rest of this maximal activity. During a maximal event like this, other energy sources would consist of glucose and glycogen, fueling a person in order for them to perform and create energy for this particular type of exercise. Working in this particular way will also create many harmful waste products. These consist of lactic acid and also carbon dioxide. The recovery phase for maximal events such as this particular one can take up to some time due to the fact that the body will have to remove this buildup of lactic acid that occurs when using this energy system. 400 meters is a medium intensity and medium duration activity, as the 400 meter similarly uses energy systems that are similar to the 100 meters. However, this event would require these systems to be working for a considerable amount of time longer. So, the main energy systems would be the ATP/PC system until 10 seconds is up, and then the lactic acid system would be dominant to finish the event. Working in this particular way would be mostly anaerobic and therefore would cause a dramatic buildup of lactic acid as well as carbon dioxide. This particular recovery for this sport would also take some time to complete recovery, as the body will need to maintain all metabolic factors in order to help remove this lactic acid. This means that for this sport, EPOC would be different to a maximal activity, as this is working anaerobically for a longer amount of time, meaning the buildup of waste products would be greater, meaning the slow components of EPOC would take longer, and if breathing rate was maintained, the fast components would still do their job as usual. A marathon would use the aerobic system as the dominant system to provide energy, as this system is most efficient in creating ATP and is also good for long duration events such as this one. The main fuel for this particular event would be glycogen stores as well as fat stores, and would be working at an RER of 0.8 or higher because of this. Waste products would include the lactic acid system and also lots of water and heat during this event, as this is a very long duration to be exposed to this kind of exercise for. The different demands of this exercise will mean that the components of EPOC would occur in recovery, and something like a marathon would take from days up to weeks to recover, in terms of things such as fats and glycogen stores, as well as the removal of all lactic acid built up, therefore differing from the other events, as they are of different intensities and durations. The recovery process for the data we can see above, here and here, shows us that heart rate and blood lactate were dramatically increased during this exercise when the threshold was reached, which you can see here and here, and the dramatic increase happens is where the threshold is. This means that in terms of recovery factors such as heart rate, blood lactate and breathing rate would also have to be maintained straight after in order to not drop too dramatically and shock the body. As we can see in the graph, levels of blood lactate and heart rate do increase very high as this is maximal, meaning that recovery for this would take a while to remove or convert all this lactic acid into other waste, as well as other waste such as water and CO2.